afternoon. This is Algebra 2, Unit 7.1, logarithmic functions, inverses of exponential functions. Think about the inverses. Remember how cool those were? Now you get what logarithmic functions are, and you can impress your friends, your family, and whoever else you want that you really get logarithmic functions, because I hear a lot of people go, I never understood logs. They're just the exponential functions inverted. And remember exponential functions like 2 to the x? That just was the sequence where every time you moved to the right, it went up by a factor of 2, so they multiplied to go up like that. Or we would do a decay where it was going down, let's say by a factor of 2, you'd be cutting it in half as you went to the left. So now we're just going to take across that inverse line and we're going to flip that, and you're going to get logarithmic graphs, and you're going to see how to work out logarithmic equations. They'll really make sense, guys. Math should always make sense. Okay? So here's the first graph, a graph of 2 to the x. I went ahead and plugged in the points, and I graphed it right here. So you know an inverse is just flipping those around. So I flipped those around, and I graphed the inverse, how it looks. That is a log function. The cool thing is, on the exponential function, I'm off camera. Let me just tip this down just a little bit. I apologize. Whew. Let me see if I can get it real quickly. There we go. Ooh-ah! There we go. So, the domain going left to right on this black line is all real numbers. There's no limitation. But on the range, remember, you can't have a exponential function in the parent source that crosses the 0. You won't get a 0 here on the output, because if you multiplied, you just get zeros. You wouldn't be able to go any further with your pattern. So it will not touch 0, and it goes to infinity. The asymptote, the line that it will not touch, is actually that x-axis. So the asymptote is x equals 0. Maybe we should put a slash through it showing it'll never be equal to 0. Okay? So now we go over to our inverse. Even though you don't know what the equation is, you know that this is a log, because I've already told you that the inverse of exponents is the logarithm functions. So remember, with inverses, our range and our domain flip. So we now know our range is all real numbers, and our domain is 0, infinity. Now let's look at our blue graph and see if that fits. Sure enough, that is our, oh, I'm sorry, I didn't quite do that the way I should have, probably. Well, it still works. Yeah, I did do it the way I should have. I'm sorry. Okay, so our asymptote is this y-axis, because that's going to switch just like this was, so it's y can't equal 0. And our domain, just like the range was here, it's going to be from 0 out, and it can't equal the 0, and then the range is all real numbers, up and down. Okay? Okay, next thing, I want to show you how the equations work. Exponents, if I give you the exponent 2 to the third, I'm sure you would all just go 2 times 2 times 2, that's 8. If I give you the log 2, 8, log base 2, 8 is how you'd read that. You might not know that the answer is 3. But here's some little keys. And this is something that I always think of. In exponents, this number here is referred to as the base. So just remember, the base is always at the base of your log. And then you just flip your x and your y. Okay? So flip your x and your y, and you say log 2 of 8, you're asking how many multiples of 2 do you need to get 8? Okay? Here's the definition. Positive numbers, y and b, where b is not equal to 1. There's the base. Log b to the y equals x if and only if b to the x equals y. Okay? And I actually have students, when they do these, oftentimes they will come down and they'll go like this, and they just flip-flop those numbers. So they take this one over here equals that one over there. Okay? That's one of their tricks that they've taught me. Here's some other important vocab. Common log has a base 10, and instead of showing it as log 10x, they won't show the 10. Now, here's an important thing. This is what you have in a calculator. You only have a common log in a calculator. You don't have a log of any other base. So we do have to learn later how to convert those, put them in a calculator. A natural log, remember the e from the exponential unit that we did? The e represents continuously compounded interest. So obviously when we deal with the inverse of these interest gaining accounts, we're going to be wanting to figure things out on the other direction too on those accounts. So instead of having log EX, we never write that. It is ln x. ln is log EX, and that will be in the calculator as well because we use it a lot in money. You'll see some of that in this unit. Pretty cool stuff. Okay, so let's just do a few problems. 7 squared equals 49, the way that you'd see that in a log question would be log, oh, I'm sorry, I wrote that wrong. The base here is 7, so the base there should be 7. So I'm saying log base 7, 49, would equal 2. In other words, 7 squared is 49. Not too hard, right? Now on this one, there's no base here, so you know it's a 10. So you're saying log 10 is 1,000. Log 10, 1,000 is what? You're asking, what exponent on 10 gives you 1,000? It would be 3, so your answer would be 3 here. Okay, now, if I give you the function is 2 to the x, then the inverse function equals log 2 to the x. One way to remember this is my base, and as I'm undoing it, I would have 2y equals x, and then I would flip-flop those, and I would have, actually I would do it the other way. I would have 2y equals x, and so on my inverse of that, to solve that problem, I would say my base 2 log 2 x equals y. Okay, so that's kind of how you'd step through solving it. It's kind of rough to see this way. I think it's easier to see up here with these. Okay, that's how the inverse works. So now we're going to evaluate a few. We're given the function f of x equals log 2 to the x, and they're saying plug in 16 for that. In my mind's eye, what I'm saying is 2 to what power equals 16. And I would just count it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, so it would be 4. Now, 2 to what power equals 1/8. This one might be harder to count out. I might have to go, oh, that's 1 over 2 cubed. In order to flip it down there, I need a negative exponent. Okay? In order to flip it to the other side, so it's 2 to the negative third equals 1/8. 2 to what power would equal 1 over 32? That's equal to 1 over 2 to the 5th. Bring that back up, that would be a negative 5, so it's negative 5. When would we have an exponent causing this base to equal 1? Hopefully you're saying 0th power. Good, good. Anytime you see a 1 right there on a log, you know the answer is 0. That's actually a property that we'll have here on one of the lessons. So graph the log 1/2 to the x. On each of these, I wrote it down. Please pause the video, copy this down, because you're going to need it when you are asked to graph one. Just what my thinking is. So I plug in a fourth, a log 1/2, 1/4. I'm saying to what power is 1/2 to make it 1/4? It would be squared. Because 1/2 squared will be 1/4. 1/2 to the first is 1/2. That's how I chose these. 1/2 to the 0th is 1. Anytime you have an answer of 1 in a log, or not an answer, but an x value of 1 in the log, then it's going to be 0. This, the 1/2 would have to flip up, so we know we're at a -1, -2, -3. Please write those down. Pause this, write those down, and think through them. So now I just come over where x is a fourth, I'm at 2. Where x is at a half, I'm at 1. At x is 1, I'm at 0. That's what I call my vertex right there. At 2, I'm at -1. And at 4, I'm at -2. And at 8, I'm down at -3. So you can see that's a sketch of my log. Okay? Last one, write a function from the graph. Okay, this one can get kind of tricky, but not bad if you remember doing it with writing the function from the graph on exponentials. It's very similar. Go back and watch that movie some, and as you get better with it, you'll get better with this one. So the first thing we look at is the H shift. H is left-right. You can spot it off of the asymptote. Always look for the asymptote. Write down this list. It'll help you. My asymptote here is at -2. So I know that my H shift is -2. In the exponentials, we always look for the K shift first. Now in this one, I notice that my sign of my A is negative because I have flipped it around. Do you see how it's a reflection of my parent function? Parent function being right here, I listed it so that you know the base. It's 1/4 x. Anyway, the new one is flipped from that. So I know that I've got a negative sign on that A. Okay, now to look at the K, here's what I do, is I spot where my vertex is in my parent function, the 0, 1. And now I adjust for my asymptote of 2, so I go down, or my asymptote, my H value of 2. So I said down, but it's really to the left, so it's 1, 2, and so there is my shift down, and I see that it crosses right here at -1 on the K, so -1. That's my HK is -2, -1. I get it from where my 0, 1 is here. That's what I call my vertex. That's my HK of my parent function. When I adjust for the asymptote, I go down 2. Where it crosses is at -1, so I know that -1 or -2, -1. Now I take it back to my. Let's see if I gave you the. Oh, maybe I didn't. I didn't. Now I take it back to my log parent function rule, so it's log. I take it from my parent. 1/4 x. Now my H is -2, so that would be a +2. My K comes afterwards, so it's a -1. And my A comes in front, it's just a -1. So you can put -1 or negative log. And that is my function. Transformed, okay? That's good enough. I hope that wasn't with the other lesson. It might be. Okay, well, I'll catch you later in class on that one. Just write it in your notes.